The pursuit of transmutation stands as alchemy's most enduring and ambitious goal, representing humanity's ancient desire to transform the mundane into the precious. For centuries, alchemists across cultures devoted their lives to the seemingly simple yet profoundly elusive task of converting base metals like lead, tin, and copper into the coveted noble metals of silver and gold. This dream was not merely about wealth creation, but represented a deeper philosophical quest to understand and manipulate the fundamental nature of matter itself. The stories of successful transmutation became legendary, passed down through generations of practitioners who believed that with the right combination of knowledge, technique, and perhaps divine favor, they could unlock the secrets that would allow them to reshape the very essence of metallic substances. The historical record reveals both the persistence and the ultimate futility of these early efforts. Tales of miraculous transformations filled alchemical texts, often accompanied by elaborate descriptions of mysterious processes and cryptic formulas that promised to reveal the path to metallic transmutation. Yet among the more honest practitioners, a different story emerged. Cornelius Agrippa, a respected occultist and alchemical researcher, provided one of the most telling admissions of the field's limitations, when he acknowledged that despite years of experimentation with hermetically sealed crucibles and carefully controlled conditions, he and his colleagues could never produce more gold or silver than what they had originally placed into their apparatus. This confession highlighted a fundamental problem that plagued alchemical practice: the inability to create precious metals from truly base materials, despite countless claims and elaborate theoretical frameworks that suggested such transformations were possible. The reason for these consistent failures remained a mystery to alchemists for centuries. But modern science has provided a clear explanation for their inability to achieve their goals. Chemical transmutation, as the alchemists understood and attempted it, is fundamentally impossible because it requires changes at the nuclear level rather than the molecular or atomic level that chemical processes can affect. The transformation of one element into another demands alterations to the number of protons in an atom's nucleus, something that cannot be accomplished through the heating, mixing, distillation, and other chemical techniques available to historical alchemists. Their tools and methods, no matter how sophisticated or carefully applied, could only rearrange existing atoms and molecules, not transform the essential identity of elements themselves. Ironically, the ancient dream of the alchemists has been realized in the modern era, though through means they could never have imagined. High-energy nuclear chemistry has made transmutation a reality, demonstrating that the fundamental goal was not impossible, merely beyond the technological capabilities of earlier centuries. The most dramatic example of this achievement occurred at CERN, where scientists successfully transmuted lead into gold using a particle accelerator. This process involved firing lead atoms at tremendous speeds toward one another, creating collisions so violent that they ejected 3 protons from some of the lead nuclei, effectively transforming them into gold atoms. The success represented a triumph of modern physics and engineering, proving that elemental transmutation could indeed be accomplished when sufficient energy and precision were applied to the task. However, this modern achievement also revealed why alchemical transmutation remained economically impractical, even when technically possible. The CERN experiment, while scientifically successful, produced an almost incomprehensibly small amount of gold, approximately 29 trillionths of a trillionth of a gram, that existed for only a fraction of a second before decaying. The energy costs required for this process far exceeded any possible economic benefit, making it clear that nuclear transmutation, while possible, would never serve as a practical method for gold production. Earlier successes in nuclear transmutation had demonstrated similar limitations, with mercury being converted to gold in 1941 and bismuth achieving the same transformation in 1980, but always at energy costs that made the process economically unfeasible. These modern achievements thus fulfilled the alchemical dream in principle, while simultaneously explaining why the ancient practitioners, despite their dedication and ingenuity, could never have succeeded with their available methods and understanding of matter. The theoretical foundations that guided alchemical practice emerged from a sophisticated understanding of metallurgy and natural philosophy that evolved over centuries, beginning with the practical observations of Greco-Egyptian craftsmen and eventually developing into comprehensive theories about the fundamental nature of matter itself. The earliest alchemists in the Greco-Egyptian tradition approached their work from a distinctly practical perspective, focusing primarily on the tinging or coloring of metals rather than attempting complete elemental transformation. These pioneering practitioners discovered that they could manipulate the surface appearance of various metals, giving them the lustrous qualities associated with silver, gold, red copper, or other desirable finishes. Their techniques involved sophisticated applications of heat, chemical treatments, and surface modifications that could dramatically alter how metals appeared to the eye, creating convincing imitations of precious materials from more common base metals. The reasoning behind this surface-focused approach revealed a logical progression in alchemical thinking that would prove influential for generations. The Greco-Egyptian alchemists observed that if they possessed the knowledge and skill to transform the outermost layers of a metal, changing its color, texture, and apparent composition, then it seemed reasonable to assume that similar processes could be developed to extend these transformations throughout the entire substance. This represented more than mere wishful thinking. It reflected a systematic approach to understanding material properties based on the belief that surface characteristics were indicative of deeper structural realities. If the appearance of a metal could be altered to match that of gold or silver, these early practitioners reasoned, then the underlying essence of the material might also be susceptible to similar manipulation through the application of appropriate techniques and substances. The most significant theoretical advancement in alchemical practice occurred during the flourishing of Islamic scholarship in the Abbasid Caliphate, particularly through the influential work of the school associated with Jabir ibn Hayyan in Iraq. This intellectual revolution built upon the ancient philosophical foundations laid by Aristotle, who had proposed that metals formed through the interaction of gaseous exhalations deep within the Earth's interior. The Arabic alchemists took this concept and refined it into a more specific and workable theory, arguing that these subterranean exhalations consisted of two fundamental substances, mercury and sulfur. This mercury-sulfur theory represented a crucial shift from the surface-focused approaches of earlier practitioners to a comprehensive understanding of metallic composition that could theoretically explain the formation of all known metals. According to this revolutionary framework, every metal in existence resulted from the fusion of mercury and sulfur in specific ratios and under particular conditions. The theory suggested that the varying properties of different metals, their hardness, color, malleability, and other characteristics, could be explained by the proportions in which these two fundamental substances combined and the circumstances under which their fusion occurred. This theoretical model provided alchemists with what appeared to be a logical pathway toward achieving transmutation. If all metals were indeed composed of mercury and sulfur in different ratios, then it should be possible to decompose any given metal into its constituent components, and then recombine these elements in new proportions to create entirely different metals through what they termed art or artifice. The mercury-sulfur theory gained considerable credibility through empirical observations that seem to confirm its basic premises. The most compelling evidence came from the behavior of galena, a common lead mineral composed of lead sulfide, when subjected to heating processes. When alchemists roasted galena in their furnaces, they observed that it released the distinctive, acrid odor of sulfur, providing direct sensory evidence for the presence of this substance within the mineral. Simultaneously, the heating process left behind liquid lead that bore a striking resemblance to mercury in its fluid, metallic properties before it cooled and fixed into its solid form. This empirical confirmation seemed to validate the theoretical framework perfectly. Here was a natural process that demonstrated the decomposition of a metal-bearing substance into its supposed fundamental components of mercury and sulfur, exactly as the theory predicted. The observation that lead could be extracted from a sulfur-containing mineral while displaying mercury-like properties during the process provided alchemists with what they considered scientific proof that their understanding of metallic composition was fundamentally correct, encouraging them to pursue increasingly sophisticated attempts at artificial transmutation based on these theoretical foundations. The historical reality of alchemical practice centered fundamentally on tangible laboratory work, with practitioners dedicating their lives to the actual physical transformation of metals and the pursuit of legendary substances like the philosopher's stone. These dedicated experimenters approached their craft with the same seriousness and methodical attention that characterizes any scientific endeavor, spending countless hours in their laboratories heating, distilling, combining, and manipulating various materials in pursuit of their ambitious goals. Beyond the famous quest for metallic transmutation, alchemists developed an impressive array of secondary technologies and pursued numerous practical applications of their knowledge. They worked extensively on creating life-extending medicines, believing that the same principles governing metallic transformation could be applied to human health and longevity. Additionally, they sought to develop powerful solvents, including the legendary alkahest, or universal solvent, which they theorized could dissolve any substance and thus serve as a crucial tool in their transmutation efforts. The documentation of alchemical procedures reveals both the sophistication and the ultimate limitations of their approach. Many alchemical texts provide remarkably detailed protocols for the early stages of various processes, describing precise measurements, specific heating temperatures, careful timing, and elaborate apparatus configurations with the kind of technical precision that would be recognizable to any modern chemist. However, these same texts invariably become increasingly vague and grandiose as they approach the critical moments of actual gold generation or philosopher's stone production. At these crucial junctures, the clear technical language gives way to mystical terminology, appeals to divine intervention, or what might be characterized as hand-waving. Elaborate but ultimately meaningless descriptions that obscure rather than clarify the essential steps. This pattern suggests that while alchemists possessed genuine technical skills and made real discoveries in the preliminary stages of their work, they lacked the theoretical understanding necessary to achieve their ultimate goals, and often resorted to mystical explanations to bridge the gaps in their knowledge. Rather than dismissing these historical practitioners for their impossible aspirations, their work deserves appreciation for the remarkable qualities they brought to their investigations. Alchemists demonstrated an extraordinary commitment to innovation, constantly developing new techniques, apparatus, and approaches in their pursuit of transmutation. Their experimentalism was genuinely scientific in spirit, involving systematic testing of hypotheses, careful observation of results, and continuous refinement of methods based on empirical evidence. The daring they displayed in pursuing such ambitious goals, often in the face of skepticism or even persecution, reflects a boldness of vision that has characterized many important scientific advances throughout history. Perhaps most importantly, their work was infused with a profound awe of nature and a deep respect for the complexity and mystery of the natural world, attitudes that remain essential to genuine scientific inquiry. The modern tendency to interpret alchemy primarily as a spiritual or psychological discipline represents a significant departure from historical reality, despite its appeal to contemporary audiences seeking deeper meaning in ancient practices. This interpretation, while offering a lovely idea and providing a wonderful modern framework for understanding personal transformation, fundamentally misrepresents what historical alchemists were actually attempting to accomplish. The spiritual interpretation of alchemy gained prominence primarily during the 19th and 20th centuries through the work of figures like Mary Ann Atwood and, most influentially, the psychoanalyst Carl Jung, who saw in alchemical symbolism a rich source of metaphors for psychological development and individuation. Jung's psychological interpretation of alchemical texts, while intellectually fascinating and therapeutically valuable, projected modern psychological concepts onto historical documents that were primarily concerned with practical laboratory procedures. The presence of religious and spiritual symbolism in alchemical texts should not be confused with evidence that alchemy was fundamentally a spiritual discipline. Alchemists living in Christian societies naturally imbued their work with the religious mythology and symbolism that permeated their entire cultural context. Just as practitioners of virtually every craft and trade during these periods incorporated spiritual elements into their professional activities. This religious dimension reflected the worldview of their times, rather than indicating that their primary focus was spiritual transformation rather than material manipulation. The historical importance of alchemical laboratory work cannot be overstated, as it was precisely through their hands-on experimentation with materials and processes that alchemists developed many of the secondary technologies and discoveries that would later prove crucial to the emergence of modern chemistry. Without the dedicated laboratory efforts of these practitioners, working with actual substances in pursuit of actual transmutations, the accumulated knowledge of chemical properties, reactions, and techniques that eventually formed the foundation of scientific chemistry could never have been developed, making their practical work an essential precursor to later scientific advances. Since chemical transmutation remains fundamentally impossible through the methods available to historical alchemists, the numerous claims of successful metallic transformation throughout history must be explained through either deliberate fraud or sophisticated chemical procedures that created convincing illusions of transmutation. The reality behind these alleged successes reveals a fascinating intersection of genuine technical skill, creative deception, and the exploitation of natural phenomena that could produce seemingly miraculous results to observers unfamiliar with the underlying chemical processes. Fraud represented what might be considered the most straightforward and distinctly human explanation for transmutation claims, constituting an enduring problem that plagued alchemical practice from its earliest recorded history. Even ancient practitioners like Zosimus, the renowned Egyptian alchemist, documented concerns about fraudulent practices within their community, suggesting that deceptive techniques were recognized as a persistent threat to legitimate alchemical work. One of the most dramatic examples of alchemical fraud involved Georg Hanau, who boldly promised Duke Friedrich that he could produce 25 metric centers of gold from ordinary iron through his transmutation processes. During what was intended to be a convincing demonstration of his abilities, Hanao's young apprentice secretly introduced actual gold into what was supposedly a hermetically sealed vessel, creating the illusion that the transformation had occurred through alchemical means rather than simple substitution. When this deception was eventually discovered, Hanao faced a punishment that reflected both the severity of his crime and the dark humor of his executioners. He was hanged on a gibbet constructed from the very iron he had claimed to transmute, with the structure mockingly covered in gold leaf as a permanent reminder of his failed promises. Beyond outright fraud, many apparent transmutation successes resulted from sophisticated chemical procedures that exploited naturally occurring phenomena to create convincing demonstrations of metallic transformation. The process of transmutation via reduction, particularly through cupellation techniques, allowed skilled practitioners to produce genuine precious metals from seemingly base materials by using intense heat to vaporize bulk substances while leaving behind heavier precious metal components. The mineral galena provided an excellent example of this principle in action, as this lead sulfide ore frequently contained trace amounts of silver embedded within its crystalline structure. Alchemists developed powerful custom-built furnaces capable of generating the extreme temperatures necessary to vaporize the lead component while preserving the silver, which would remain as a small but genuine bead of precious metal that appeared to represent the successful transmutation of lead into silver. Similarly, practitioners discovered that certain silver coins, particularly branthalas, contained small quantities of gold that could be isolated through careful heating processes using specialized sands as flux materials, allowing the silver to be poured away and leaving behind a tiny bead of pure gold that seemed to demonstrate successful transmutation. The techniques of multiplication and debasement represented another category of sophisticated chemical manipulation that could create the appearance of successful transmutation while actually reducing the purity of precious metals. These processes involved taking genuine gold or silver and carefully infusing it with cheaper substances such as copper, zinc, tin, and arsenic, typically using liquid mercury as a substrate to facilitate the mixing process. While this approach could dramatically increase the apparent volume of precious metal available, it came at the significant cost of debasing the material's actual value and purity. Forensic analysis of historical artifacts has provided compelling evidence of these practices, as demonstrated by examination of the Winslow-Saylor medallion, which was allegedly produced through the transmutation of silver into gold, but was found to contain only approximately 48% gold, 43% silver, and nearly 8% copper, along with detectable traces of tin, zinc, and iron. The creators of such debased items often employed additional chemical treatments to help their products pass contemporary assays, including dipping the finished pieces in diluted nitric acid, which would selectively attack the cheaper metal components while leaving the gold surface relatively untouched, allowing the items to pass superficial tests for precious metal content. The sophisticated techniques of cementation and plating represented perhaps the most technically advanced approaches to creating convincing imitations of precious metals through surface manipulation and careful layering processes. Cementation involved the meticulous joining of different metal layers, often compiled into thin strips, which were then fused using precisely controlled heat and specialized salts to create materials that appeared to be genuine precious metals. Success in this technique required extraordinary temperature control, as the metals needed to fuse sufficiently to create a convincing bond without melting completely into an obviously artificial alloy. Plating processes involved even more complex chemical manipulations, beginning with the dissolution of gold using acids and mercury to produce a gold amalgam that could be applied to the surface of other metals, particularly silver. After application, the treated metal was carefully heated and washed, leaving behind a genuine gold layer that could pass many contemporary tests for authenticity. The imagery associated with these processes became deeply embedded in alchemical symbolism, particularly the use of aqua regia, a mixture of concentrated nitric and hydrochloric acids capable of dissolving gold to create what alchemists termed portable gold. This dissolution process produced a distinctive color progression from green to red that inspired the famous alchemical image of the green lion eating the sun, representing the acid's consumption of the gold. Additionally, alchemists developed numerous recipes for creating materials with the visual appearance of gold or silver from entirely non-precious metals, such as techniques for producing convincing gold through the careful fusion of iron pyrite with copper, demonstrating the remarkable level of chemical sophistication that could be achieved even without genuine transmutation. The enduring legacy of alchemical practice extends far beyond its failed attempts at metallic transmutation, establishing the fundamental technological and methodological foundations upon which modern industrial chemistry would eventually be built. Despite their inability to achieve their primary goal of converting base metals into gold, alchemists developed an extraordinary culture of experimentalism that proved invaluable to the advancement of chemical knowledge. Their relentless pursuit of transmutation required them to push the boundaries of existing technology and develop entirely new approaches to manipulating matter, creating a tradition of systematic investigation and technical innovation that would prove far more valuable than any successful transmutation could have been. The experimental mindset that characterized alchemical work, with its emphasis on careful observation, systematic testing, and continuous refinement of techniques, established methodological principles that remain central to chemical research today. The technological innovations developed by alchemists represent some of the most significant contributions to the advancement of chemical science, providing the essential tools and techniques that would enable later generations of chemists to make breakthrough discoveries. Alchemists designed and constructed sophisticated furnaces capable of achieving and maintaining the high temperatures necessary for their complex procedures, developing heating systems that far exceeded anything previously available, and establishing principles of thermal control that remain relevant to modern chemical processing. Their creation of specialized laboratory equipment, including an extensive array of glassware, ceramic vessels, and metal apparatus, provided the foundation for the systematic manipulation of chemical substances under controlled conditions. Perhaps most importantly, alchemists developed and refined fundamental chemical processes such as sublimation and distillation, techniques that became absolutely essential to the separation, purification, and analysis of chemical compounds, and continue to serve as cornerstone procedures in contemporary chemical laboratories. The development of powerful novel chemicals by alchemical practitioners represents another crucial dimension of their lasting contribution to chemical science, particularly their groundbreaking work with acids that would prove essential to countless future chemical applications. Through their extensive experimentation with various materials and processes, alchemists discovered methods for producing acids of unprecedented strength and purity, opening entirely new possibilities for chemical manipulation and analysis. Their work with brass preparation and the complex procedures involved in distilling cinnabar to extract liquid mercury led them to develop techniques for producing sulfuric acid, one of the most important industrial chemicals in human history. This achievement required not only technical skill, but also a sophisticated understanding of chemical relationships and reaction conditions that demonstrated the genuine scientific capabilities of alchemical practitioners. The progression from sulfuric acid production to the creation of even more powerful chemical agents illustrates the cumulative nature of alchemical innovation and its far-reaching implications for chemical development. Once alchemists had mastered the production of sulfuric acid, they discovered that this substance could be further processed through distillation with other materials, particularly alum and sal ammoniac, to produce aqua regia, the legendary mixture of acids capable of dissolving gold itself. This achievement represented a remarkable technical accomplishment that required precise control of chemical reactions and demonstrated an advanced understanding of acid chemistry that would not be fully explained theoretically until centuries later. The development of aqua regia was particularly significant because it provided alchemists with a tool for manipulating gold in ways that had previously been impossible, allowing them to dissolve, transport, and redeposit this most precious of metals through purely chemical means. These specific procedures and the secondary productions they enabled ultimately became the foundational technologies upon which chemical modernity was built, creating a direct lineage from alchemical laboratories to modern industrial chemistry. The techniques developed by alchemists for producing, handling, and utilizing powerful acids became essential components of countless industrial processes, from metal refining and pharmaceutical production to the manufacture of fertilizers and explosives. The laboratory equipment they designed evolved into the standard apparatus used in chemical research and production facilities worldwide. The experimental methodologies they pioneered, with their emphasis on systematic observation, careful documentation, and iterative refinement of procedures, established the basic approach that continues to guide chemical research today. Without the centuries of dedicated experimentation conducted by alchemical practitioners, the rapid advancement of chemical science that characterized the 18th and 19th centuries would have been impossible, as later chemists built directly upon the technological foundations, procedural knowledge, and experimental traditions that alchemists had painstakingly developed through their pursuit of transmutation. The irony of alchemical legacy lies in the fact that while practitioners never achieved their primary goal of creating gold from base metals, their systematic efforts to accomplish this impossible task generated the tools, techniques, and knowledge base that would prove far more valuable than any amount of transmuted gold could have been.